This time I have an Onkyo A8190, and the problem with this one is it's not getting enough power. And I know I'm probably confusing some people here. They're thinking that there's a power supply problem. Well, there is a power supply problem, because you see, this one here is for use over in Europe. It's a 240 volt unit, and well, we don't have 240 volts here, so I'm going to make it work. Let's check it out. This is what is this thing? This is a beast. This is an A8190. Beast of an amplifier. 2 channels. Like, this thing's got some power. It doesn't have that much power, only 100 per channel into 8 ohms. But the problem is, well, I can't really use it here in its current form, because you see, this is not a domestic model. This one requires 240 volts, 360 watts of power at 240 volts. So this is a big one, but it's a European model. What I don't know is whether the transformer is a dual winding or whether it's a single winding. So I guess first things first. I mean, I guess I could run it on 240 volts. I do have 240 volts here. Just like everybody in North America, they have 240 volts available, just not at the plug, unless you wire specifically. My bench plugs are wired so that I can have 240 volts if needed. I basically just need to plug 2 cords into it and pick the hot from one and the hot from the other and ignore the neutral. And I could have 240 volts, but that's really not that practical. It would only be operational in one place. I guess I could run at my kitchen. My outlets in the kitchen all are 240 ready. And my office has 240 volts. I have 2 circuits, so I could make up an adapter cable and give this 240. Or I can investigate as to what it would take to switch this to 120. Again, I don't know I don't know how they've done it, whether they've got a dual winding on here. And that's what we're going to look at. So a lot of these transformers, they were set up so they could be wired either way. They could be wired for 120 or 240. Fortunately, this is just a 240 volt only. There's only one winding on here. What I need to do is I need to see what the output voltage is on the secondary. I think there's only one secondary, or is there 2 on this? Oh, there's 2 secondaries. So yeah, it's got a center tapped and it's got a straight output. So what I can do is I can disconnect the secondary, and we can measure. I can run it on 120, and I can measure what the voltage is, and it will be half. Or I could give it 240 and just measure what the voltages are on here, and see if I can find a transformer that's got a similar output. I have a transformer here, and I can measure the voltage on here and see whether this one here is providing the same voltages. This is a 120 volter. And if I have a transformer that the 2 windings are close enough, then I could swap the transformer out. So first things first, let's just cut the wires and remove the transformer. That's the first thing. So we'll just clip these wires off. That's one winding. There's our primary. I know, someone's going to say, just use a step-up transformer. Yeah, that's the easy way out. We don't do easy here. That's just an extra piece of equipment. There's no point in doing that. That's what amateurs do. They just basically utilize a step-up transformer to step up to 240 volts. I'll just cut these wires down here closer to the transformer. It just makes it easier to get to. There, okay. That's my secondary. right? We've got a center tap, and the two reds are the main winding, and the black is the center tap. That's so we can have our split voltage for positive and negative. And now all I need to do is just power up the transformer. I can power this up off of 120 volts, and we can measure what the power is on these wires and these wires, and that will tell me what secondary voltage I need on another transformer, and hopefully this other one that I've got here will be close. I mean, if it's close, it'll work, right? As long as it's not higher than what this one is. And again, these voltages, if I power this up on 120 volts, they will be half of what the voltage I need, because running at 120 volts will give me half the voltage on the secondary. So first things first, let me just strip the wires back here so that we can measure what the output is on the transformer. I'm actually going to pull it out of the unit itself and work on it outside of the chassis. Those screws are out. Lift out the transformer. I'll just turn this over on the side for now. Don't need this right here. And now we'll apply 120 volts to the input and measure the output. Alright, transformer has power. Let's measure the green winding. Green winding has 5.6 volts AC. So call it 6. This is a 12 volt winding. Green is 12 volts. So we'll just mark that down here. The green winding is 12 volts. The other winding, and these are isolated from this other one, at least they should be. This other one here has a total of 41 volts. So in other words, 82. So it should be 20 volts per winding. Right, so it should be 40 for center tap and 80 across. So that's a 40, 0, 40. 40, 0, 40. That's a pretty standard voltage for a power transformer for a stereo equipment. And there should be nothing between these windings here, because these should be a separate winding. Oh, are these connected? They shouldn't be, but maybe they are. Looks like they are connected. We'll just unplug that and just check this for ohms. Yeah, they're open. They're not connected. They're independent winding. I was just getting, this is the mega ohm range, right? So these windings are completely separate. Good. I was just getting induction between the two windings, because it's a high impedance meter, so we're looking at resistance here. So we've got nothing. We're open. Up between here we've got continuity, 0.3 ohms. Between these ones here we've got 0.9 ohm. So I'm done with that one. Let's just make sure that stays unplugged. I've got another transformer over here, which I've already got power, I think, to. And we'll look at the windings on here and look for a 40, 0, 40 and a 12 volt winding off of this one. Do I have them already? I might even have these marked. But we'll see what this one does. So if we look at this transformer, this one actually has 3 separate windings. You've got one winding here, which is the center tap. We can confirm that if we look at the meter in ohms mode. If I can get those reflections to go away so that the meter shows up on camera. It would be nice if this had a little stand. You know, it'd be great if this meter had a stand. The only way that the Fluke is actually better than this is that it stands up. I'll have to make a stand for it. Okay, oops, ohms. So we got a winding here, 0 ohms. Right, we expect it to be pretty close to that, and 0.9. So that's a center tap there. That's one winding. It's open between these ones, right? So this is a standalone winding. These ones here, we have continuity between all 4 of these windings, and it's open here as well. And then this one here is its own standalone winding. So we've got 3 separate windings. What we need to come up with is, I'm hoping we're going to have a 40, 0 and 40 or close by, and a 12 volt AC. So let's power this thing up. I'll put the meter in AC, so I don't have to wait for the auto voltage select. I can just put it in AC volts. And we're going to measure across, we'll start at this end. What do we have here across this one? We have, this is only 3 volts, so that's no good. I'm looking for 12 volts. So where can we get 12 volts? 4.9. Well, 15 across there, 26 across there, 31 across there. Okay, what about here? 10 point, okay, that's almost 12 volts. 11 volts, that's probably close enough. What about here? That's 21. What about across here? 10.5. So this is going to be a center tap, right? That's a center tap there. That's the center tap, and we've got 2 windings. We got 15, 10, 10, and 15. So across these 2, we're going to have 21 volts. So I'd probably use 10. Yeah, so we'll use one of these here, 10 volts. That'll give me 10 volts across there. What about this one over here? We know this is the center tap. What do we have on this? We have 38 volts. Well, that's close to 40. So across the 2 of them here, we have 76 volts. Well, that's close to 80. That's going to be good. So I can use this winding here, and I can use a winding across here to give me 12 volts. Excellent. I'll just mark what I'm going to use here. I'm going to use that, and I'm going to use these ones. That's 80 volts. So, excellent. I think I can make this amplifier work. How cool is that? Let's install this transformer in that box, and we'll do some wiring and make it work. First things first, I have to make the hole fit the screw. There, that'll fit, and the other one on this side. Surprised that this old drill still works. This is like, I don't know, 19 years old, I guess. And the batteries are still, well, they don't hold that much. They don't hold that good a charge, but they still work. Nickel cadmium, 14.4 volt. I did have my dad's old variable speed Craftsman AC powered drill, if necessary, but the other ones did the job. I'm only going to be able to put 2 of the screws in, as that's all that lines up with this transformer, but I think 2 screws will probably hold it good enough for what we need in here. After all, it's not going anywhere. Okay, transformer is secured. I'm going to take the AC cord, the plug that was on the old transformer, and I'm going to connect it here and connect it over here to the fuse. Now there's a second fuse under here. So, I mean, I guess I could probably even eliminate this portion. I could eliminate this and just connect directly over here, because there is a fuse over here already. And there's a fuse over here. So it doesn't really need to be double fused. So I could remove this board and just hook my wires up directly. Hook my wires up directly here, right? The 2 red and the black, and hook up my 12 volt wires here down to the board. That might make for a cleaner installation. So let's just pull that little board off top. I'll use my new solder sucker. See how well this thing takes off big lugs like this. Does that answer your question? I think my tip is starting to wear out. It's a soldering iron tip. It's got some oxidation on one side, so it doesn't transfer heat as well. We'll clean out the solder pult, or the clone of the solder pult. Just push it down like that and just give it an extra little crank, and that'll pop the end out, and then I can clean all the crap out of the end here. So the pins I'm going to use are these two here. So what I'm going to do is I'm going to just shorten the other ones a bit. I won't cut them right off, but I will shorten them down. Take that one down, that one down, that one down, leave these two up, that one down, and that one down. And now we have 2 higher pins, 3 higher pins, and these 2 are the ones that are not going to get used. And what we'll do is I'll put some heat shrink tubing over these ones. They're not going to be used. And here's our power input over here, and we'll heat shrink some tubing on there as well. So I'm going to get some heat shrink. We'll just isolate the ones that we are not going to use and get this thing connected. Oops. Put our heat shrink tubing on our secondary leads. Now remember, the polarity doesn't matter, it's AC. I just gotta make sure that the black one is on the center tap. We'll attach them, solder them, and then heat shrink. I don't know whether this unit works. I'll tell you that right now. This was given to me a while back. So I did some work for. He had it and he said, hey, I got this old Onkyo 240 volt amplifier that I got no use for. You can have it. So I've been actually sitting on this thing for several years before deciding what to do. And just today I thought, you know what? This would make a good project to get this thing running. And since I had a transformer that I pulled out of another scrap unit that I gutted, what a perfect solution. Get a nice big old powerhouse amp up and running on domestic voltage. Alright, I got to connect the 12 volt wires down to the input points where they were initially wire wrapped. I'm just going to solder them down. So I'll tin the points first.
just to make it easier to hook up the wires once I get this tinned.
Okay, 12 volt line is now connected. Now we just have to do the 120. Got a couple more wires. We'll just take them from the power switch over to the transformer. Almost ready for testing. The only thing I need to do now is just get a power cord for it, because the line cord does not have a plug on the end, so I got to dig up a cord set to put on here. I have another cord set to put on here. We'll just pop out the strain relief on the back of this one first. It should pop out of here, no problem. Alright, got the old one out. Get the new one in. Get the cord in place and hook it up. Then we'll install the strain relief again last. And of course we have to make sure that the polarity is correct. So for that we can use the meter. It's a marked cord. It should be, the stripe should be on the neutral side. So the larger prong is the neutral, and that should be that one, which it is. And the hot side is the one without the yellow stripe. So yellow stripe is going to go to the neutral side over here, and the one without the yellow stripe to the hot side. This unit is now ready for testing, so let's power it up and see how much smoke we get. Right, I'm going to power this up on the dim bulb tester just because it hasn't been powered up for a while, so there's probably going to be a fair bit of inrush as the caps charge, so we don't want anything going boom immediately. Volume is at minimum, power on. There we go. Okay, nothing
spectacular happened. We can give it full power. The light just came on momentarily as the cap's charged up, and this unit has got power. I got a green light indicating that it's ready to put out some power. All right, make sure that everything's set to flat, balance. Record is off. We're on CD input. We have speakers 1 selected. And are we going to hear any sound? Let's see here. I hear something. Why am I not hearing any sound? Oh, that's the record select. Try CD. Haha. Weird. When I have a different input selected, I crank it up. Maybe it's just leakage. That's probably leakage. CD direct. CD. This has got a contra bass. This actually sounds really, that knob's kind of broken, bent. If it was straightened, it'd probably break if I try to straighten it. I got my inputs reversed. Oh well. Muting, 20 dB muting. CD direct bypasses everything. That's the record out. Tape 2 record. So it's got a bunch of switches. It's got tape 1 record. I'll show you the knobs on this thing. This has got lots of bells and whistles to play with. Okay, so input select, tuner, phono, CD, CD direct, VCR, video disc player, tape 2, tape 1 DAT. It's got all the inputs that you could want. I like it. It's got tape 1 record output. You can select either tuner or dub 2 to 1 or video or phono or CD, and then tape 2 you can select the same, dub 1 to 2 or dub 2 to 1. Video out, tuner off, phono, and CD. So you have 2 tape decks on here. One of them lights up. This one lights up. 2 to 1 dub. I guess we have to split. If we switch that, probably there we go. You can dub your sound from a VCR or a video disc player. That's the video mode. Or off. Or record the sound output. Tape 2 record position, it says. Okay, so it doesn't light up unless it's in that mode, but you can select 2 to 1, VCR, tuner, phono, or CD, and the same with the tape 2. It lights up as well. So light up both of them. If you're recording from the CD on one of them, it'll light up CD, the other one will light up phono. Interesting. Inputs. Gain tuner, phono, CD, CD direct, tape 1 DAT, tape 2 VDP, VCR. Over here you got stereo mono mode, and you got cartridge, moving coil or moving magnet. Tone controls. Super bass. speakers A, B, and B or B. Yeah. This is a nice amplifier. I'll have to look this one up. It's an Onkyo Integra. It's an A8190. And I don't know what power this is. It's probably 100 watts per channel. What does it say? Well, maybe more. It's got lots of output transistors. Look at this. It's got 4 outputs per channel. SK, 2 SK A1491s and SKC 3856. So I think those are probably just bipolar transistors. I don't think this is MOSFET. They're SK branded, which is Senken. So 2SC 1491 and 2SC 3855 and 2SA 1491. But you look at the outputs here, right? This is going to give you a lot of power. Big capacitors here. This has got more than enough juice. This transformer. Got an in-phase transformer. Okay, well I'm pretty happy. As they say on here, it's got in-phase signal coupling system, CD direct digital ready amplifier. That control could use cleaning. I don't know if I can straighten it. I get nervous when I see shafts that are bent, because sometimes when you try to straighten them, you break them, and then you're kind of screwed. We'll see if I can straighten it well. Maybe it will. It's not too bad now, but it's still a bit. It's a little better than before. Not perfect, but it's not as noticeable as it was before. I don't want to risk breaking it. Because I know that I'll turn these speakers inside out without this thing even putting out a sweat. So I don't want to turn it too loud. Hey, okay, I think I pretty much covered it. It's done. So that was a fun one. Now I've got a useful amplifier that I could keep or sell or whatever, but I used a part that I had just sitting around here that was useless. I wasn't using it for anything. I got my heat shrink compound or heat shrink tubing, so I don't have to worry about anything shorting out. Same here. Here I get shocked though. Yeah, I used a transformer that was just sitting around doing nothing, and now I've got a functional unit. So I hope you guys enjoyed this little modification, making a good unit out of a bad one. There's only one thing left to do. You know what that is, right? That was all that needed to be done. Quick look at the inputs and outputs on the back. We've got our phono and tuner inputs up here, and our CD input. CDs have gold inputs. My ground wire is broken on here, so I have to ground it with the left. We got our, phono and tuner and CD. We got our tape 1, record play, tape 2, record play, and then we've got video inputs for video displayer input, VCR, record and play, preamp outputs, and video monitor out. Of course, just a composite output because this was made back in the day when that's all we had. We had CRT monitors and VCRs and laser discs and video disc players. And we didn't even have DVD back in the day of this. Anyway, that's it for this one. Thanks for watching. We'll catch you on the next one. Bye.